Let us see what else we can explore. If we go back further, then we will see the moment in which the quark soup began to crystallize into protons and neutrons. This happened after the Big Bang, 1 microsecond to about 1 second thereafter. This is where the creation of the world began. In a moment, you will see a picture of CERN and other large colliders, where scientists want to recreate the beginning, go back to the soup of protons and neutrons, so to speak, and then watch how things really unfold, how quarks and gluons again create protons and neutrons, and so on. For this purpose, a collider was created in which 2 large nuclei, such as gold, move toward each other, each possessing a large amount of energy, about 1,200 giga-electron volts per nucleon. A head-on collision occurs in the center, and at the moment of impact, of 150 to 200 mega-electron volts is obtained. And as a result of this interaction, everything is in the center. If in Kelvin, it is written as 4 times 10 to the power of 12 degrees. This is one 100 giga-electron volt gold nuclei, and this is another 100 giga-electron volt nuclei. The STAR experiment, which was done at the relativistic collider at Brookhaven, showed a very interesting graph. So I want to show you that there was a very high density in this place, a very high temperature. There were quarks and antiquarks here, but they had not yet destroyed each other because this area was rapidly expanding, and then they saw a very interesting model. This is what the creation of the world looked like. The proton and antiproton are obtained, the deuteron and antideuteron, helium-3 and antihelium-3, helium-4 and antihelium-4 are also obtained. A completely symmetrical picture, the world and the anti-world. This was published in the journal Nature, and I was the reviewer of this work. This was a brilliant paper. I want to mention that we also want to do this type of research in Dubna. Here is a picture of the large collider that is currently being built called Nika, which will enable us to look at such graphs and study these interactions. And this is, in fact, information about the so-called second phase transition, which shows us what happened 1 microsecond after the Big Bang. The experiment was repeated at CERN. There they saw the same graph with more energy statistics, about 15 times more. And now the question is, realistically, what was the results of all of this? What followed was that we understood how hydrogen, helium, lithium, and beryllium were formed, after which the curve fell sharply and nothing else came into being. All other elements that we see in cosmic rays or on Earth today have nothing to do with this. This is very strange. All of them were then formed in completely different processes. And only helium and hydrogen tell us the story of when the universe began to form after the Big Bang. Now let's get back to the subject of our conversation. This is what the world looks like today. The black squares, and there are 287 of them, are what has survived from the moment the elements were formed to the present day. The yellow ones are what was obtained in nuclear physics by artificial synthesis. But this terra incognita is something that can, in principle, be obtained if we ever get here. Therefore, hydrogen, helium, deuterium, lithium, beryllium, and boron were formed in very small quantities in around 3 to 20 minutes. All of the other elements were formed much later.